Bismillahirrahmanirrahim. Assalamu alaikum friends. I'm Abdul Mateen Yunus representing MasterG.com. Today we are going to discuss another interesting topic with you, that is evolution of Gs. Before starting a topic, I request my new viewers kindly subscribe my channel and press the bell icon so that they can get my new uploaded videos easily. Now moving towards the topic evolution of Gs. So first of all, we will discuss its introduction. Simply, the G stands for generation. While you connected to internet, the speed of your internet it depends upon the single strength that has been shown in the alphabet like 2G, 3G, 4G, right next to the signal bar on your home screen. Each generation is defined as a set of telephone network standards which detail the technological implementation of a particular mobile phone system. And there are 5 types of generations, that is 1G, 2G, 3G, 4G and 5G. The speed increases and the technology used to achieve the speed also changes. For example, 1G offers 2.4 kilobyte per second, 2G offers 64 kilobyte per second and is based on GSM, whereas 3G offers 144 kilobyte per second to 2 megabyte per second, whereas 4G offers 100 megabyte per second to 1 gigabyte per second and is based on LTE technology. The aim of wireless communication is to provide high quality, reliable communication just like wired communication, optical fiber. And each new generation of services represents a big step, a leap rather, in that direction. This evolution journey was started in 1979 from 1G and it is still continuing to 5G. Each of the generations has standards that must be met to officially use the G terminology. Each generation has requirements that specify things like throughput and delay that need to be met to be considered part of that generation. Each generation built upon the research and development while happened since the last generation. 1G was not used to identify wireless technology until 2G or the second generation was released. This was a major jump in the technology when the wireless networks went from analog to digital. Now, we will discuss 1G, that is first generation. This was the first generation of cell phone technology. The very first generation of commercial cellular network was introduced in late 70s with a fully implemented standard being established throughout the 80s. It was introduced in 1987 by a telecom known today as Telstra. 1G is an analog technology and the phone generally had poor battery life and voice quality was large without much security and would sometimes experience drop calls. These are the analog telecommunication standards that were introduced in 1980s and continued until being replaced by 2G digital telecommunications. The maximum speed of 1G is 2.4 kilobyte per second. Then the next generation is 2G. Cell phones received their first major upgrade when they went from 1G to 2G. The main difference between the two mobile telephone systems, 1G and 2G, is that the radio signals used by 1G network are analog, while 2G networks are digital. Main motive of this generation was to provide secure and reliable communication channel. It implemented the concept of CDMA and GSM, provided small data services like SMS and MMS. Second generation 2G cellular telecom networks were commercially launched on the GSM standard in Finland by Radio Linja, now part of Ilsa OH, in 1991. 2G capabilities are achieved by allowing multiple users on a single channel via multiplexing. During 2G cellular phones are used for data also along with voice. The advance in technology from 1G to 2G introduce many of the fundamental services that we will use today, such as SMS, internal roaming, conference calls, call hold, and billing based on services. For example, charges based on long distance call and real-time billing. The maximum speed of 2G with General Packet Radio Service, that is GPRS, is 50 kilobyte per second or 1 megabyte per second with enhanced data rates for GSM evolution, that is HEDGE. Before making the major leap from 2G to 3G wireless networks, the lesser known 2.5G and 2.75G was an interim standard that bridged the gap. Now, we will moving towards the 3G, that is third generation. This generation set the standards for most of the wireless technology we have to come to know and love. Web browsing, email, video downloading, picture sharing, and other smartphone technology were introduced in the third generation. Introduced commercially in 2001, the goals set out for third generation mobile communication were to facilitate greater voice and data capacity, support a wider range of applications, and increase data transmission at a lower cost. The 3G standards utilize a new technology called UMTS as its core network architecture Universal Mobile Telecommunication System. This network combines aspects of 2G network with some new technology and protocols to deliver a significantly faster data rate. Based on a set of standards used for mobile devices and mobile telecommunications, use service and network that comply with the International Mobile Telecommunication 2000, that is IMT 2000 specifications by the International Telecommunication Union. One of the requirements set by IMT 2000 was that speed should be at least 200 kilobyte per second to call it is a 3G service. 3G has multimedia services. 3G increased the efficiency of frequency spectrum by improving how audio is compressed during a call, so more simultaneous calls can happen in the same frequency range. The UN's International Telecommunication Union IMT 2000 standard required stationary speed of 2 megabyte per second and mobile speed of 384 kilobyte per second for a true 3G. The theoretical maximum speed for HSPA Plus is 21.6 megabyte per second. Like 2G, 3G evolved into 3.5G and 3.7G as more features were introduced in order to bring about 4G. A 3G phone cannot communicate through a 4G network, but newer generations of phone are practically always designed to be backward compatible. So a 4G phone can communicate through a 3G or even 2G network. Then, the next generation is 4G, that is fourth generation. 4G is a very different technology as compared to 3G and was made possible practically only because of the advancements in the technology in the last 10 years. Its purpose is to provide high speed, high quality, high capacity to users while improving security and lower the cost of voice and data services, multimedia, and internet over IP. Potential and current applications include amended mobile web access, IP telephony, gaming services, high-definition mobile TV, video conferencing, 3D television, and cloud computing. The key technologies that have made this possible are MIMO, that is multiple input, multiple output, and OFDM, that is orthogonal frequency division multiplexing. The two important 4G standards are WiMAX has now fizzled out and LTE has seen widespread deployment. LTE stands for Long-Term Evolution, is a series of upgrades to existing UMTS technology and will be rolled out on Telstra's existing 1800 MHz frequency band. The maximum speed of 4G network when the device is moving is 100 megabyte per second or 1 gigabyte per second for low mobility communication like when stationary or walking. Latency reduced from around 300 meters to less than 100 meters and significantly lower congestion. When 4G first became available, it was simply a little faster than 3G. 4G is now at the same as 4G LTE, which is very close to meeting the criteria of the standards. To download a new game or stream a TV show in HD, you can do it without buffering. Newer generation of phones are usually designed to be a backward compatible, so a 4G phone can communicate through a 3G or even 2G network. All carriers seem to agree that OFDM is one of the chief indicators that a service can be legitimately marketing as being 4G. OFDM is a type of digital modulation in which a signal is split into several narrowband channels at different frequencies. There are a significant amount of infrastructure changes needed to be implemented by service providers in order to supply because voice call in GSM, UMTS and CDMA 2000 are circuit switched. So with the adoption of LTE, carriers will have to be re-engineer their voice call networks. And again, we have the fractional part, that is 4.5G and 4.9G, making the transition of LTE getting us more MIMO. And the last generation that we have to discuss in this lecture is 5G. FG is a generation currently under development that's intended to improve on 4G. 5G promises significantly faster data rates, higher connection density, much lower latency, among other improvements. Some of the plans for 4G include device to device communication, better battery consumption, and improved overall wireless coverage. The maximum speed of 5G is aimed at being as fast as 35.46 GB per second, which is over 35 times faster than 4G. Key technologies to look out of: massive MIMO, multimeter wave, small cells, all Wi-Fi. All the new technologies from the previous decade could be used to give 10 GB per second to a user with an unseen low latency and allow connections for at least 100 billion devices. So friends, a chart is placed on your screen which is showing the difference between 1G, 2G, 3G, 4G and 5G in between them. I hope you will understand it better. If you have any query or you want to give us any suggestion, then kindly comment us below. Inshallah, we will meet you in the next lecture with a new topic. That's for all. Huda Hafiz.